Jai Hind to all. Myself Mahendra Dwivedi, EN Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today we will see the lecture on electric drives. Subject code is KEE075. This content is taken from Unit 1, and today we are going to discuss about speed torque convention and multi-quadrant operation. So let us see the content. So here we will see classification of methods of speed control, speed torque convention and 4-quadrant operation, and then classification of load torque. So let us see one by one. So classification of methods of speed control. Here we will see there are different types of classification. Like in the first group, there are uncontrolled constant speed of rotation during normal operating conditions. The requirement, it may be bidirectional as well. So if we will see, speed may be unidirectional or bidirectional. So magnitude of speed is not an important consideration, and the speed is permitted to fluctuate in response to the variation in magnitude and direction of load torque. So example is drives for pump, ventilators, compressors are the example of unidirectional rotation. For bidirectional rotation, the drives of a crane can be cited as an example. In the second group, these drives provide step changes in speed during normal operating conditions and maintain constant speed within the step. Rotation may be unidirectional or otherwise with and without speed control during transients. It is used in various machine tools. Example, in drilling machine, an electric drive has to provide different speed for different materials of the workpiece and diameters of the drill. Step control is also used in heavy duty cranes, lifts, mine winders in order to have appropriate speeds. Now in the third group, these drives provide smooth or with narrow step control of speed within certain ranges during normal operating conditions. A drive of an electric locomotive can serve as an example where smooth speed control of traction motor is required. So main drive of rolling mill is another example of drives of this group, but compared to locomotive traction drive, the requirements of speed control are different here. In the fourth group, these drives have to provide control for fixed position of load. Drives for lifts and mine winders are examples of drives of this group. These drives are used for automatic production lines, skip lifting and loading installations in sugar and chemical industries. In the fifth group, these drives are used for position control in response to a command. They are also called servo mechanisms. They are widely used in recording and controlling instruments, copying devices for machine tools, drive systems for radio and radar antennas, etc. So if you will see, drive can also be classified on the basis of either they are having the motors for continuous duty, short time duty and intermittent duty. So if you will see dynamics and transients, so drives can be classified on the basis of uncontrolled transient period and controlled transient period. Now let us see speed torque conventions and multi-quadrant operations. Because most of the drives are having motors and motor will have these 4 quadrant of operation. So we will see one by one, where we will see forward motoring, which is occurring in first quadrant, forward braking, or nowadays which is very useful, that is regenerative braking. So this comes under second quadrant. then reverse motoring. So there are applications in the industry where same motor has to drive in the forward direction, and for some other application it has to drive in the reverse motoring mode. So we will see reverse motoring mode, and then reverse braking, or normally fourth quadrant is occupied for plugging type of braking operation. So here important is, if we will see forward motoring mode, so there basically we want to set, or we want to have convenience of direction of speed, that is omega. So speed is omega, and okay, so this is speed and torque. So as we all know, power is the combination of speed and torque, and there we have to set the reference direction of the speed and torque, so that output power will be depending upon what is the speed and what is the torque. So in the first quadrant, if we set the direction of speed like this and direction of torque like this, so we can say that speed is positive, because when motor is moving in anti-clockwise direction, so that is taken as the reference direction of the speed. Similarly, torque is also produced in the anti-clockwise direction, and therefore torque is also positive here, and therefore power is the combination of motor speed and motor torque, and therefore power is also positive here. So in the motoring mode, as we all know, power flow is from source to the load side, that is load is our motor. So power is flowing from source to the motor, and since direction of speed and direction of torque is same, and therefore we can say current is also positive here. So in the first quadrant of operation for forward motoring mode, so direction of speed, direction of torque is positive, as well as power is also positive, and direction of current is also positive. But if we will move towards second quadrant, where we can also see torque is getting negative. So for the braking operation, speed is still in the same direction. So speed is in the same direction, but the direction of torque reverses due to direction of current, which is also being reversed. So there we can say speed is still in the same direction and brakes are applied, but direction of torque is reversing, direction of speed is in the same direction, and therefore power is negative. So we can say power is the combination of speed and torque. So one of the direction of speed or torque is reversed, and therefore negative signs come here. Since power is negative, it means that power flow is from load to the source, and since power flow is from load to the source, and therefore current is also negative, because direction of current is changing since power flow is taking place from load to the source. And this is the fundamental which is used in electric vehicles also, and in the applications where this condition occurs, there we can say this is the regenerative braking. So whenever we can make the arrangement so that power flow can take place from load to the source, so that will make the condition of regenerative braking. Similarly, coming to the third quadrant, so like we have seen a lot of applications where some motor is carrying some object from one place to another place, and then the motor has to come again at its initial position. So once it is reaching the final position, from there same motor will rotate the material in reverse direction. So there, if we will see, the direction of speed will change, omega m. Direction of motor torque is also reversed, it is also changed, and therefore speed is negative, torque is negative, and therefore if we will see, power is positive. So whenever power is positive at the load point, it means that power flow is still from source to the load, because power is positive, and therefore we can say the current is negative here. So current will also be positive, not negative, because in the motoring mode current will always be positive, that is, it will flow from source to the load. So this is reverse motoring mode, and whenever motoring mode will be there, we all know that power is always positive. Similarly, in the reverse braking mode, so if we will see, the direction of torque is positive, motor torque is positive, but direction of speed is negative, and therefore if we will see, torque is positive, so current has to be positive, and therefore the output power is negative, and it is the braking mode. So as we can see in the plugging, what we are doing, we are just changing the terminals. Like if we talk about the DC motor, so positive is connected to negative and negative is interchanged to the positive. Similarly, in the induction motor, if we will see, we will change the sequence of direction of A, B, C phases. So this is the convention, and on the basis of this convention, we will see multi-quadrant operation of a motor, or we can say a drive is able to run the motor in all the 4 quadrants, and that's why we are using the drives nowadays in the industrial applications. So let us see the multi-quadrant operation. So for drives which operate in one direction only, forward speed is their normal speed. In loads involving up-down motion, the upward direction of motion is treated as forward rotation, and downward direction is treated as negative direction or reverse operation. For reversible drives, the forward direction of rotation is chosen arbitrarily, and the motion in opposite direction gives reverse speed, which is assigned the negative sign. So positive motor torque is defined as torque which produces acceleration or the positive rate of change of speed in forward direction. So positive load torque is opposite in direction to the positive motor torque. A motor operates in 2 modes, that is forward motoring, where direction of torque and direction of speed is same, which is taken as a conventional direction of speed and conventional direction of torque. So second is reverse motoring. So the direction of torque and direction of speed in the reverse motoring, as we have seen in previous slides, is reversed, or it is opposite to the conventional direction of the speed and torque which is taken. Similarly, in motoring, it converts electrical energy to mechanical energy supporting the motion. In braking mode, it works as a generator and converts the mechanical energy into electrical energy, therefore opposing the motion. So during braking operation, we can say that it is working as a generator, and generator supply the electricity. So their load is giving the power back to the source. So power developed by motor gives as product of torque and speed. So in first quadrant we have seen power is positive. Power is positive. In second quadrant power is negative. Power is negative. In third quadrant again power is positive, and in fourth quadrant power is negative. So whenever power is positive, power flow will take place from source to the load, and whenever power will be negative, it means that power is flowing from load to the source, but it is not possible every time to make this condition, and power can be absorbed by source. So we have to think about that. We have to take extra care to make the power flow from load to the source. Now with an example, we will try to understand all four quadrant operation of a drive. So basically, if we will see, drive is containing motor. So drive contains a lot of components, and one of the component is motor. So it is a only single motor. So we can say this is the motor. We can see this is the motor. This is the motor, and motor is connected with the rope to the counterweight and loaded cage. So in all four operation, we can think this is a loaded cage, and motor has to operate in conventional direction. So motion is upward. So counterweight as well as motor operation will bring this cage to the upward direction. Similarly, here if we will see, here the direction, this is the empty cage, and this has to bring to the upward direction. So counterweight is enough to carry the empty cage, because in normal situation counterweight is greater than the empty cage. So although direction of speed will be same, but motor is having the braking operation, and therefore torque which is produced is opposite to the direction of the speed of the motor. Similarly, in the third cage, empty cage has to bring down, and therefore since counterweight is greater than empty cage weight, and therefore motor will operate in the reverse direction, and motor torque is also applied in the reverse direction. Similarly, here if we will see, we have to bring down the loaded cage, and therefore since loaded cage is weight is greater than counterweight, and therefore we have to apply the braking operation. So direction of the speed will be in this direction, opposite to the conventional direction of the speed, but motor torque which is being applied, that will be in the opposite direction, because this is the braking operation. So this is the real world application. This is the application of a lift. So with the help of this, we can understand four quadrant operation of a drive. So load torque has been shown constant and independent of the speed. With a low speed voice, this is nearly true, as forces due to friction and windage can be compared to be negligible as compared to that of gravity. So if we will see classification of load torque, so basically these are of two types, active load torque and passive load torque. Thank you.